Aging is the buildup of error. That's all aging is. The buildup of error. Error in our DNA, errors in protein synthesis, errors at the atomic and molecular level, and that's where quantum computers comes into picture. Because quantum computers live in the quantum world. Immortality is, therefore, possible. The quantum computers will be able to isolate the process which makes aging possible.
The theory of quantum immortality suggests that every time you face death, your consciousness shifts into a parallel universe where you continue living. But is this science or just a mind-bending illusion? Let's explore the fascinating mystery of quantum immortality and its shocking implications. Could we actually live forever? The science behind immortality. According to Michio Kaku, nothing in the fundamental laws of physics dictates that we must die. In fact, he suggests that both biological and quantum immortality might be possible, at least in theory. On one side, biological immortality could be achieved by reversing aging at the cellular level. Scientists now understand that aging is essentially a buildup of molecular damage in our DNA, proteins, and mitochondria. If we can repair these errors, we may be able to extend human life indefinitely. On the other side, quantum immortality proposes that death itself might be an illusion. Based on the many worlds interpretation of quantum mechanics, every time you encounter a life-threatening event, there could be another reality where you survive. From your own perspective, you would only ever experience the versions of reality where you continue living. Both ideas seem radical, but if either one turns out to be true, they could completely transform our understanding of life and death. Can science reverse aging? Biologists and tech entrepreneurs are pouring billions of dollars into research aimed at stopping or even reversing aging. According to Kaku, the secret lies in cellular repair. Every time a cell divides, tiny errors accumulate in the DNA. Over time, these errors lead to tissue breakdown, organ failure, and ultimately, death. But what if we could correct these errors at the molecular level? Some creatures already possess this ability. Take the Hydra, a tiny freshwater organism capable of regenerating indefinitely. Unlike humans, its cells don't accumulate damage in the same way. If scientists can unlock this regenerative process in humans, aging could become a thing of the past. The role of quantum computers in unlocking immortality. Kaku believes that quantum computers will be crucial in understanding and reversing aging. Unlike traditional computers, which process information in a linear manner, quantum computers operate with probabilities, allowing them to simulate complex biological interactions at the atomic level. By modeling the intricate processes behind DNA repair, cellular aging, and molecular damage, quantum computers could help scientists pinpoint the exact mechanisms responsible for aging and, more importantly, how to stop them. Are we already quantum immortal? While biological immortality focuses on halting the aging process, quantum immortality suggests we might already be functionally immortal, just in a way we don't realize. If the many worlds interpretation is correct, then every time we die in one universe, our consciousness could seamlessly continue in another, where we survive. But if that's the case, why don't we remember dying before? Could quantum mechanics really explain the mystery of death? The quantum physics behind immortality. According to Kaku, to truly grasp the concept of immortality, whether biological or quantum, we must first understand quantum mechanics. Unlike classical physics, which follows predictable laws, quantum mechanics reveals a universe governed by probabilities, superpositions, and multiple realities. At the heart of this discussion is one of the most debated theories in quantum physics, the many worlds interpretation. What is the many worlds interpretation? In quantum mechanics, particles don't exist in a single state until they are observed. Instead, they exist in multiple states simultaneously, a phenomenon known as superposition. This was famously demonstrated in the double-slit experiment, where light behaves both as a wave and a particle depending on how it is measured. The many worlds interpretation, MWI, takes this concept to its extreme. It suggests that every quantum event causes reality to split into multiple versions, each representing a different possible outcome. This means that every decision, every roll of the dice, and every life or death moment creates parallel universes where each possibility plays out. If this interpretation is correct, then consciousness may never experience death, because there will always be a reality where you survive. How could quantum immortality work? Quantum immortality builds upon the logic of the many worlds interpretation, but applies it to consciousness. Imagine you're in a life-threatening situation, such as a plane crash. In most realities, you don't survive. But in some rare branches of the multiverse, you do. Since you can only experience the realities where you are still alive, from your own perspective, you would never truly die. Even if everyone else in your original universe sees you as gone, your consciousness would persist in a version of reality where you survive. Quantum immortality versus biological immortality. While biological immortality aims to prevent aging and physical decline, quantum immortality suggests that your mind might already be eternal. However, there's a major issue. If quantum immortality were real, why don't we remember past deaths? Why don't we wake up in different realities with clear proof that we've crossed into another version of existence? One possible explanation is that memories are locked to each universe. When you shift realities, your past memories remain behind, making the transition seamless and undetectable. What does Michio Kaku think? Kaku acknowledges that quantum mechanics is filled with paradoxes and mysteries. While some physicists take the many worlds interpretation seriously, others remain skeptical. The biggest question remains: does consciousness follow the same quantum rules as particles? The science and limits of the theory Kaku has long been fascinated by the strange implications of quantum mechanics. While he recognizes that the many worlds interpretation is a well-regarded theory within physics, he also stresses that it remains unproven. The idea of quantum immortality, where consciousness never truly experiences death, but instead shifts into surviving realities, is an extreme extension of this theory. But is there any scientific evidence to support it? The illusion of survival, survivor bias, creates a deceptive perception. Every person alive today has, by definition, survived every life-threatening event they've ever encountered. If they hadn't, they wouldn't be here to reflect on it. This can give the false impression that we're simply lucky, rather than experiencing something more profound, like quantum immortality. Does consciousness even follow quantum rules? One of the strongest counterarguments against quantum immortality is the possibility that consciousness doesn't adhere to quantum mechanics at all. While subatomic particles behave according to quantum principles, human cognition arises from complex biological and neural processes. If consciousness operates purely under classical physics, then quantum immortality would have no bearing on how we perceive life and death. The mystery of near-death experiences. Some researchers speculate that near-death experiences, NDEs, could provide anecdotal evidence for quantum immortality. Many survivors of extreme accidents describe eerie sensations, missing time, altered perceptions, or even the feeling of slipping back into reality. Could these experiences be glimpses of consciousness shifting between parallel worlds? While intriguing, neuroscientists argue that NDEs are more likely the result of biochemical and psychological reactions to trauma, rather than evidence of reality hopping. The challenge of testing quantum immortality. If quantum immortality were real, proving it would be nearly impossible. Unlike traditional scientific experiments, it lacks repeatable and measurable evidence. If consciousness does shift between realities upon death, there would be no way for an individual to remember past deaths or for others to observe the phenomenon. Without a means to track consciousness moving between timelines, the theory remains untestable. A radical question: what if death is an illusion? Even if quantum immortality remains speculative, it forces us to reconsider fundamental questions. Is death truly the end, or is it merely a transition? Does consciousness operate on quantum principles, or is it strictly biological? If there's even a small chance that quantum immortality is real, what implications would it have for science, philosophy, and our understanding of existence? Could this change our understanding of life and death? If quantum immortality were real, it would upend our traditional beliefs about mortality. In classical thought, death is absolute, an irreversible conclusion to one's existence. But under the many worlds interpretation, what we perceive as death could simply be the moment where consciousness shifts into an alternate timeline where we survive. Does death even exist? From a first-person perspective, quantum immortality would mean death is an illusion. Every time an individual faces a fatal event, they would only ever experience the reality in which they survive. This raises a deeply unsettling possibility. Are we functionally immortal, but only to ourselves? If so, would we eventually find ourselves in bizarre, improbable realities where survival has defied all odds? A new perspective on existence. If quantum immortality holds any truth, it suggests that life isn't about a single, fixed version of oneself, but rather an infinite number of variations, each navigating their own branching timeline. Death, then, would be relative. While external observers would see others die, the individual's consciousness would continue seamlessly. The universe is stranger than we imagine. If quantum mechanics governs our perception of life and death, reality might be an endlessly branching structure where every possibility unfolds in some version of existence. The question then becomes, does consciousness actually obey quantum mechanics? Or is this simply an unfounded assumption? Michio Kaku's thoughts on consciousness and quantum mechanics. Physicist Michio Kaku has frequently discussed consciousness in relation to quantum physics, though he remains cautious. While some physicists take the many worlds interpretation seriously, Kaku acknowledges that it remains unproven. The key question is whether consciousness itself is subject to quantum mechanics. If it is, then the idea of an endlessly branching reality for every individual may not be so far-fetched. However, if consciousness is purely a classical phenomenon, then quantum immortality is likely just an interesting but flawed theory. Can future experiments prove a connection? Current research into quantum mechanics focuses primarily on subatomic particles, but some scientists are exploring its potential role in biological processes. Key areas of investigation include quantum biology. Some studies suggest that quantum effects like superposition and entanglement may play a role in biological processes, such as photosynthesis and enzyme activity. If similar quantum mechanisms exist within the brain, they could redefine our understanding of consciousness. Quantum cognition. A growing field examines whether human decision-making follows quantum probability rules rather than classical logic, hinting at potential quantum properties in cognition. Neuroscience and quantum computing. As quantum computers advance, they may offer new ways to model the brain and determine whether quantum effects contribute to consciousness. What if the many worlds interpretation is proven? Even if scientists confirm that the many worlds interpretation is true, it wouldn't automatically validate quantum immortality. However, it would raise profound questions about reality, consciousness, and what happens when we die. Can quantum computing help decode the true nature of consciousness? If parallel universes exist, is there any way to access or communicate with them? While quantum immortality remains purely theoretical, it forces us to rethink what we know about life and death. Whether or not the theory holds, it challenges us to reconsider reality itself. Let us know your thoughts in the comments. And don't forget to like, subscribe, and turn on notifications for more mind-blowing content.